Okay, let's take some of what we know now about standard form, factored form, and vertex form and apply it to everything. Apply it to life. So a soccer ball is kicked and its height in meters after t seconds is given by the formula when height equals -4t squared plus 16t. How long after the ball is kicked, is the ball at a height of 12 meters? So we're thinking about here, when is height equal to 12? So we can sub that right in. Now, because there's a squared, and the main concept, one of the main concepts of grade 10 is quadratics, you shouldn't just take the square root and take the square root, and then all of a sudden the t disappears. We have standard form, but it's kind of rearranged. So let's bring everything to one side, and because that is negative, we have the option to bring it to the positive side. Or we can just bring everything to the right, however you feel. Right now it doesn't matter too much, but let's just bring it all to the right, because we're used to seeing y equals, or in this case h equals. So take away 12, take away 12. Now the first thing we always do, we have standard form, factor. So if we factor this, common factor for everything, oh look at that, -4. And we're left with t squared minus 4t plus 3. This is now a simple trinomial. So two numbers that multiply to 3 and add to -4 are -1 and -3. So while we have now factored this, remember the whole point of this is not that same equation. This is at what time is the ball at a height of 12, because we put 12 in. Just because we brought them all to one side to factor using the skills we have, this is actually technically a new parabola, but what we've shown is we have figured out the times, and there's two different times when the height is 12. So what this graph would actually look like if we were to factor it there is it's kicked from the ground, goes up, and it comes down. And so what we've done by subbing in 12, when is the height 12? There and there. And so by factoring, we found those 2 points which correspond to 1 second and 3 seconds. So we can say, therefore, the ball reaches a height of 12 meters 1 second and 3 seconds after being kicked. If we wanted to know the actual curve of the parabola, we would have factored that equation. It's a common factor, -4t, which would leave t minus 4, which gives us x-intercepts of 0 and 4. Okay. Example 2. Football is kicked off the ground. Off the ground. There's our y-intercept. Reaches a maximum height of 6 meters after it has traveled horizontally for 14 meters. That information is our vertex. Our vertex is a height of 6 after 14 meters. After 24 horizontal meters, meaning that way, away from where the ball has been kicked, the football was 3 meters off the ground. Right now, that's just another point. That point is just 24.3. Determine the equation of the quadratic relation that models the path of the ball. So now, based on that information, we should choose which formula to use. Because we're given a vertex, what do you think we should use? Standard form, factored form, or vertex form? Ah, you're right, vertex form. Sweet! So remember that, vertex form. We have a vertex for H and for K. Our point, remember that those are just X and Y. So for X, sub in 24. For Y, sub in 3. Everything else stays the same. Now we need to solve for A. 24 minus 14, 10. We need to take away 6 from the right, take away 6 from the left. Math is so fair. 3 minus 6, negative 3. 10 squared is 100 times A. Divide by 100 to solve for A. Negative 3 over 100, or if we turn that into decimal, negative 0.03. Now we have an A value, we have an H value, we have a K, we have all we need for our formula. So our formula, our equation that represents that situation, X minus our vertex 14 plus the height at our vertex 6. And again, we can use negative 3 over 100 if need be, or if you feel like it. Let's do 1 or 2 examples from the back, but applying it, here we go. Long jump is a track and field event that requires speed in addition to strong jump. Strap. There are 3 phases: approach, takeoff, and landing. Approach, takeoff, landing. Ethan is a long distance jumper. During his approach, he runs on the track for 6 seconds. Ooh. Followed by his takeoff, where he leaps in the air. He remains airborne for 8 seconds. So from there to there is 8 before landing back on the ground. There's 2 x-intercepts. 2 seconds after his takeoff, Ethan is 0.3 meters above ground. So 2 seconds later, that's 8. He is 0.3. So that's just another point. Determine Ethan's maximum height above the ground. If we have 1, 2 x-intercepts, should we use standard form, factored form, or vertex form? Factored form, because we have 2 x-intercepts. So that gave us, again, x-intercepts, that x is equal to 6 and x is equal to 14. Remember, from factored form, we also have another point. We have the point 8, 0.3. That is an x, and that is a y. We have our 2 x-intercepts, which will go in for r and s. So let's sub in what we know. Now again, we want to get one number in that bracket times one number in that bracket, so let's solve. 8 minus 14. 2 times negative 6 is negative 12. Now we need to isolate the variable. Negative 0.3 divided by negative 12, negative 0.025. Turn that into a fraction, negative 1 over 40. So we have an A value. Now we want to know the maximum height above the ground. You can do this a few different ways. We can put our A value back in, complete the square. So go from standard form, complete the square. We can go to standard form and use negative b over 2a to find our axis of symmetry, sub it back in. We can use our 2x intercepts to find our axis of symmetry. A whole bunch of different things. For me, because these are solid numbers, it might be easier to add them together. 20 divided by 2 is 10, and use that 10 back in our new factored form. So when x is 10, let's solve. All the numbers are on the right. Minus 6, 10 minus 14. Enter those all into our calculator. We get. So, the highest that Ethan got was 0.4 meters off the ground. This is long jump, so we don't want to waste time going up. Realistically, that makes sense. Highest Ethan jumped was 0.4 meters off the ground. Find his height above the ground 5 seconds after takeoff. So again, y really in this situation is height. Time 5 seconds after takeoff is our x. So 5 seconds after takeoff is going to be our 6 plus 5, which is 11. So when x equals 11, y equals, we don't know. So let's solve it. We do the exact same thing. Substitute in, and y is 11. And now we solve. Negative 15 times negative 1 over 40 gives us y equals 0.375. So 5 seconds after takeoff, he's already starting to come down. It's past our axis of symmetry. We have a height. Try example 4.